Look at that. Here I am. How's it going, everyone? Today I'm doing a little evaluation of EBS. I'm going to be doing this using a tool called FIO. FIO is my absolute favorite disk benchmarking tool. Written by Jens Axpo. Jens Axpo is one of the Linux kernel folks. He's written maintainer of the IO subsystem for the kernel, and I really love this tool. And to be honest, it was one of the things that inspired me. A lot of the features that are present here were inspiring for me for when I was working on TLP stress, which is now known as easy CAS stress. Yeah, I'm pretty excited for this. So I actually haven't launched these instances yet. So I'm in the process of starting these up. So if you hear me clicking around, I'm just going to kind of talk through what I'm doing here. And you know, I've got this AMI that let's see, where is this thing? My AMIs, there we go. Is this the one that I just fired up? It's right here. Yeah, see this. So here, I'm just going to share my screen. Go ahead and share my screen here. So this is what I'm working with. Hey, Sarma, how you doing, bud? One thing I'm pretty excited about here is that I actually haven't gone through this exact thing I'm going to do yet. So there's definitely a bit of giant question marks for me, what we're going to see. But today we're going to be looking at a few different types of IO patterns with EBS. So I'm going to be firing up an instance. And if you look here, you can, I don't know how clear this is. Whoops. How easy this is to see, but we're waiting for this AMI to become ready. This AMI is something that is part of EasyCast Lab. So EasyCast Lab has this Packer build thing, and it's pretty cool. It has a whole bunch of different Cassandra versions on it, so you can actually select from 3.0, 3.11, 4.0, 4.1, and the alpha of 5.0. And I'm working on getting support for trunk. It's actually pretty easy to adjust configuration settings, and I'm doing a whole bunch of stuff for this. This tool is dual use for me. It's, I guess, 3 uses. It's really helpful here in this stream, as I'm gonna because I like to be able to fire things up and create environments and test stuff. But also in the process of like consulting, it's really helpful when people ask me questions, just have a tool that I can use, and it's kind of standardized. And you know, I don't really love setting up clusters with like CCM for doing like real world kind of testing, especially once it's performance type stuff. But anyway, the whole point is that this tool here, I'm just gonna make this a little bit smaller because we don't need to concentrate on that right now. The really cool thing about this is that I've already got like BCC tools, right? If you've seen me talk about performance before, you probably have heard me mention BCC tools. And I wrote a blog post about the topic. Oops. BCC tools are pretty cool. So BCC tools is right here. There's like all these really, really nice commands that tap into the Linux kernel that allow us to figure out like what's going on. And so I'm going to be using this today a lot. There's definitely going to be quite a bit. In fact, some of the tests that I'm going to do, I'm going to be looking at the file system and then looking at the block device. So what's really interesting about this is that you can see requests coming in through the file system, and the kind of like it won't match up one-to-one, but you can kind of see what's going on at the block device as well. So if we take our block level commands and we kind of figure out what's going on there, we can get a distribution of the types of requests that are going through the block device. We can take a look at the file system, and we can also take a look at the page cache by using cache stat. Now, one of the things to keep in mind is that the whole reason why I use this build is because I actually I don't rely on the packages from Ubuntu. The packages from Ubuntu have some issues. In particular, if you try and if you just install Ubuntu 22, like if you fire up an image and you do apt-get install BCC tools or whatever the name of the package is, it might be BCC like BPF or something like that. It just won't work right. So it's kind of a bummer. And of course, whenever you decide to do something kind of last minute, you end up paying the price. Like right now, I'm just sitting around waiting for this instance. Waiting for the AMI to be ready. But according to my Amazon control panel right here, it is ready. So I'm just going to go ahead and start this. I'm not going to share this. I don't remember I don't usually use the console, but I'm doing this kind of in the background. Let's see. So let's see what happens when we use this. Existing security group. Let's use one of my existing security groups. Hopefully my key pair is not an issue on here. Again, like I said, I'm just kind of doing this stuff for the first time. I'm definitely not going to do this on micro instance. That seems kind of crazy. So let's see now. What instances? EBS. What instances are EBS optimized? So I want to test this with the EBS optimized instance because there's really no point in not doing it. So what do we got here? Oh, it looks like the C4s and 5s are maximum performance for 30 minutes, at least once every 24 hours. Here, let me just make this a little bit bigger because now I'm starting to kind of look at stuff. So here's what's really interesting here. The reason why I'm doing this test is because EBS has these docs that are a little, I don't know if they're vague. I think they're just missing what I would like to see. The reason why I'm testing this is because EBS has gotten way more popular for running Cassandra. It used to be, not a great thing to do, but between the general purpose like GP3 and this provision IOPS, the provision IOPS are insanely fast. But the GP3 is what I'm going to be taking a look at today. So I'm going to start up that instance. But here's the bit that's really interesting. This is maximum IO size, 256 KB. So the reason why this is so interesting to me is because a lot of the times with Cassandra, especially with small reads, I advise people to go down to like the minimum amount of read ahead. So you're going to basically have 4K is like the minimum that you're going to end up doing. The reason why this is so interesting to me is because if you have to read a bunch of sequential pages off disk, like for example, let's say you're doing compaction or you're streaming. If you are using a really low read ahead, then Cassandra basically has to block in every IO operation. So if you're only pulling off 4K at a time, like my concern is that you're going to chew through IOPS faster than you would if you were doing like a larger operation. So I'm doing this for a couple of reasons. One is just to get a kind of a general sense of what happens on the device. Two, I actually wanted to get something in the project where I can use the data that I get today, and I'm essentially going to try out a thing where if we're streaming or in compaction, we can actually use a buffered reader. So instead of just relying on page cache or read ahead, we can go directly to the file for like we do now for reads. But whenever we do streaming and compaction, we're going to use a buffered reader and buffer it out as much as possible. Now, what I want to do is discover what the maximum size is. I want to find out the most efficient way to access disk, because I'm fairly confident that because of the amount of time that we spend in IO during streaming, like if every time you have to go to disk, you wait 2 milliseconds, that's a lot of time, right? If you're doing that constantly, it really adds up and it will slow down your streaming. So what I want to do is basically investigate using buffered readers with EBS and see if we can deliver faster streaming performance when using EBS drives, while still allowing us to minimize the use of read ahead. Because I think read ahead is terrible, and I'd love to see us move to direct IO in the future. But there's a whole bunch of things that kind of come along with that. It gets a little bit tricky. So, you know, that's what I'm thinking. Let's see, launch an instance. Okay, so now let me just see if I can get this instance launched. So it looks like we can go with so this is here. So we'll just use we'll use this guy. We'll go with the C4. And here's the thing, like you might find different performance from different nodes, and then there's like whether or not it is EBS optimized. So I probably, as a second test, will do like an EBS optimized versus not. Let me just pull this up here. There's nothing secret on this. Configure storage. So we're just gonna continue using this this root volume, but then we're gonna add. Let's just go ahead and add like 100 gig volume and of EBS. So now, let's see. Don't care about any of this stuff. Where is my optimized instance? Enable. Okay, good. I don't think I'm going to, you know what? We're just going to see what happens here. Maybe I messed this up. If I did mess this up, then what I'll do is I'll probably just launch it with my tooling that I normally use, because I don't really use, when you're dealing with like big scale stuff, you don't launch stuff in the console. So I never do this. And even for like, even for my personal stuff, I don't launch in the console. So I need to make EasyCast Lab support EBS optimized instances, obviously, unless it already does it implicitly. I should probably check that. Okay, so yeah, so that's there. So cool. Let's just get rid of this. We don't actually no. We'll just go in a different tab. Oops. We'll open up a new tab for this. Boom. Hopefully. Oh, one thing I wanted to mention. I switched the stream to be 1080p. If I could get, I don't know if there's any feedback. If these windows are big enough. I mean, if they're not, I can make them bigger. If anyone can just kind of like let me know what's going on in the comments, I'd appreciate it. Okay, so I got my instance. Let's see, what do we got here? Public IP. Let's see if I can. Sure. It's like no. Ah, good. Okay. So the other reason why I use this, it isn't just because of bio latency, which is really nice, like bio latency. Let's just do this real quick. So you can see here, this is the 100 gig disk that I partitioned. ls block, this is a useful command that lets you see all your block devices. So let's just go ahead and let's just do XFS on this. And we'll just go ahead and do that. And then let's see now. So mount, okay, so see how this says mount Cassandra? This is part of the this is part of my tooling. So this automatically has a Cassandra directory here, and there's a script that can be run that will actually mount the instance storage, which oops. So this should actually say, let's see, root file system. Weird. Let me make sure I get this set up right. So now when I look here, oh, maybe the C5s don't have instance storage. That's probably what's going on here. So the TLP, Easy Cast Lab. I'm probably going to call it TLP cluster a whole bunch because I did for years. It's hard to break that habit. So yeah, so this is what I'm seeing here. So see how this, you might not be able to see it, but this is dev SDB. This is this basically is the same thing as XVDB. I can't remember why the storage, why it says SDB on the control panel and then XVDB within, all of my tooling here, but it doesn't really matter. All I know is that I've got what I want. So let's just do this. Mount EBS, cool. And then we'll just mount this here. Okay, so mount EBS. Okay, so what we're going to be doing here is we're going to be using a tool called FIO. So I have the manual here, and I'm actually going to I'll drop this in the comments. If you're interested in kind of following along and like looking at what's going on, the FIO manual, the FIO manual is really, really nice. But basically what FIO does is you provided a configuration file, and the job file format is like right here. It's really easy. You can list multiple jobs and they can run in parallel or they can run sequentially. But what we're going to do is we're going to be using this RW option. And I have not pre set up any of this stuff. So, this is really this is a serious working session for me. I'm going to be using the manual. Like, I realize that it might be boring at times, but this is like literally how I work. So hopefully this is helpful. So let's see now. So what we're going to do is we're going to start here, and let's just go with, we'll just have a sequential test. So let's see now. And I realize that my keyboard is super loud. So, just enjoy it. So the RW option. So this is RW. So you'll see, read write RW equals. So we're just going to say RW equals, and then we're going to do sequential reads. We're basically just going to focus on this for the first test, and then we can do like some other fun stuff. But there's like a whole bunch of options here, like direct. This is interesting. We might be doing some direct IO, basically like lets us avoid a whole bunch of extra stuff. But the downside is that we're not going to get the full picture of how the page cache is involved. And this is partially about maximizing IOPS for sequential reads. So what I'm going to do is I'm going to be trying different versions. I'm going to be setting read ahead and running the test, and then setting read ahead to a different value, flushing the page cache, and running it again. And to flush the page cache, this is something that I always have to look up. You echo 2 and something. We'll be doing that in just a minute. So I need to look at, let's see, directory equals, we'll just do data. We'll do it in data. So all the data files that it's reading will be done there. FIO is going to make a bunch of file names. I don't really care about that. Runtime, right? Oops. Whoa. Let's just have these. I think that'll be 2 minutes. Let's see how that goes. Now it looks like I need to time base 1. So I don't know if anyone was watching the previous stream, and I got some comments about the size of the resolution, making it hard to read some of the stuff I was doing. I'm going to make this, whoops, make that bigger. Yeah, okay, you can go away now. So there's a couple different ways that we can actually approach this. One is we can set the rate at a fixed rate. We can say, let's do like 1,000. Nate, yeah, 10. Thank you, Nate. Appreciate it, man. Nice to get a little confirmation there that I'm on the right track. As you might know, I am fairly new to the streaming game, just this year. File service type. Let's use that. We use Gaussian distribution. Let's see. There's also like, what's cool is we can also mess with the like IO scheduler. Because I don't care about this environment, I'm just running as root, so it shouldn't be a problem. IO schedulers are useful for some things. Most of the time, like the main time you're going to care is if you're using NVMe. NVMe benefits massively from the use of the Kyber scheduler. There are some other schedulers, but where are we going here? Like I actually just use none for the most part because I'm not interested in it. A lot of the times what they're trying to do is like batch things together and trying to make things more efficient. But you don't really want, depending on your workload, you might not want that. So I usually just go with none. And all right, so now I want the file size. Okay. Block size. We're gonna start with 4K. This is gonna be a simple test. And now later, what I'm gonna do is I'm actually gonna parameterize this and make it so that it pulls from the environment variables, which I guess I could do now. I could even BS4. Whoops. I think this will work. BS8. And of course, it would help if I put the right settings in. So what I'm setting here is I'm just making sure, like I'm like I said, I don't really I don't have everything memorized in here, so it's like, so let's just take care of this. So this should, once I add in size here, so this is going to be a 2-minute test just to get a rough idea what's going on. So we're going to try multiple tests, but I don't want them to run at the same time. So this is where I need to configure this in the global setting. There's like a job description right here. So let's see. I think there's like, it's called like block or split or something like that. There's a setting here where, let's see. I probably should have figured this out ahead of time, but that's okay. You're learning with me. So there's a couple interesting things that I am going to be using here. I mentioned that I compile my own DCC, but I also compile my own FIO. And the reason why I do that is because the latest FIO has, hopefully it's in this version, because it'll make life a lot easier for me. There's an option where you can tell it your latency requirement. And so it'll dial in the throughput. And you can say, like, I want my P99 latency to be below X. And this is actually I added the same feature to EasyCAS stress. So if you're interested in running a cluster and you want to say, like, tell me my throughput for my read latency or my write latency of XYZ, you can do your tunings and then literally rerun the stress profile and it will figure out what your throughput is. So like a lot of the time, sometimes your goal is to reduce latency. Sometimes your goal is to improve throughput. By reducing latency, you will improve throughput. It's like if you look at queuing theory, you're in just using logic, it stands to reason that if you spend less time doing work on something, you can do that thing many more times, right? So our goal here is always to minimize latency, especially with the database, because that allows us to have improved throughput. Now, there are certain times where this might not make sense. Like if you were to use like heap settings, I guess, maybe in such a way so that you had like massive GC pauses every now and then, but like most of the time you were okay. That could be a little weird. I mean, it might have a customer impact, like some of your like 1% of your customers stuff just doesn't work. Like that's not particularly great. So I wouldn't do that. But for most of the time, it's going to be totally fine. Let's see now. What was I doing here? I think maybe it was group. Come on. No, not control group. Group reporting. Let's see. Is this it? So there's group reporting. There's to see the final report per group instead of per job, use group reporting. Jobs in a file will be part of the same reporting group unless separated by Stonewall or using new group. So what's the difference between Stonewall and new group? Stonewall says wait for the previous preceding jobs in the job file to exit before starting this one. New group, start the new, see group reporting. If not given, all jobs in the file will be the same unless, okay, so I think I can just use Stonewall here. And I might actually be able to just do it here. Let's just see what happens. I think it's not gonna. Data is not a directory. Got it. Okay. Okay, so you need to specify size. Perfect. That's what I wanted. Let's just see what happens when we try it with a 10 gig file. Okay, cool. So it's laying this first one out. We're going to get some numbers around here. So this is only configured to run it at for 2 minutes. Let's actually just, oops. Come on. Come on, guy. Making me look bad. There we go. Let's cut this down to like 10 seconds just while I debug this and we get this thing going. Once this is going, your video cam is blocking, your cam video is blocking your terminal output video. Oh, thanks, man. Didn't even notice that. Maybe I can move me. No, not gonna move me. What am I doing? All right, let's see, let's move this over here. We'll move this over here because I don't think anybody's going to be too upset if you can't read the bottom left corner of the FIO documentation. Be all right. And then this can go right here. Cool. That'll work. Okay, so this is laying this out. So let's just jump on here and see what's up. So this is laying it out. This is my fun time. Okay, so we are doing some stuff. Let's just jump on as root. No, you did not. So if I run just cache that, it's like, no way. Let's just take a quick look. So let's just do this. Oops. See what happens when I lame. Okay, gotta fix that. So this is definitely the result of you know what? Let's just see what happens. Install Python 3. Throw it on there. Whatever. So I'll just kind of explain all this. The reason why this is happening has to do with the fact that we're doing some like using this Pi, whatever this is called, PyEnv, in order to allow for multiple versions of Python to be installed on this box. And the reason why that matters is because Python 3 is required for Cassandra 4 and up, and Python 2 is required for versions 3.0 and 3.11. And I still do a lot of work with 3.0 and 3.11. So, you know, as a result, my tool has to support it. So this used to be like, let's just do Python. All right, let's just see what happens if I do this. Whoa, get out of here. Did I fix it? Maybe. Let's do cache that one. Okay. Cool. We got that now. Awesome. All right. Nice fix. Cool fix, man. So it looks like I need to just make a little note for myself to install Python 3. Okay. That's going to be fun. So this is actually kind of funny, but I'm just going to do this. Oops. I forgot which one is it. Is it target link name? Okay. Ellen, yes, user bin Python 3, user bin Python. Maybe this will work. Yeah. All right. Well, I need to take a look at that, apparently. This is what happens when you make changes, and then you just try stuff out. Okay, so this did a 10 gig file. This did 1.2. This did 1.2. So 33,000 IOPS. So that's what's interesting there is, you know, when I provisioned this, let's just do a little bit more space here. So when I provision this, let's see. What's this volume? See, this is 3,000 IOPS. So the reason why we're able to get so much more is presumably because of either that burst setting, which was here, but that doesn't really make sense. And look at this, it's actually above. So they were getting 125. So this is dancing right around the expected numbers. So what I'm wondering is if we'll run out of throughput before we run out of IOPS. So let's just take another look here. Okay, and one of the interesting things about this is these times, these 1 hour times, you can somehow get like you can sometimes hide uh, what you really want to see. So what I like to do is just go to 1 minute. You got to blow this thing up, and you got to get rid of like a lot of. Okay, 15. So look at that. Like, so this is here. When you go here, okay, so we do see that spike. Okay, so it's really important to make sure you fix this right here, because if you leave it on like average, it will smooth this out, and you'll think that you'll be like, oh, you have plenty of, you haven't used anything. And like here, it'll be obvious. So like, look at this, 5. Looking at the last 15 minutes, right? So here we actually do see this thing spike up. But if we do, okay, there we go. Look, and then, okay, this is actually a perfect example. So this spikes up here, and you see this at 4K, right? But if we change it to a second, we see it actually spiked way higher than that. So you can run out of IOPS, and you can't tell unless you go in the control panel and you do it correctly. Now, I think that it looks like they're getting a little bit better about making performance a little bit more reliable and allowing you to have like burst and things like that. But you can see here that because I let it go unthrottled, you can see that like most of the numbers are okay. Like we actually are getting pretty good performance, and then things at the very top end just sort of tank. And so one of the things that's useful in the newest version of FIO, the reason why I wanted it, just put that there for now. There is a latency thing. Latency target. So let's just try this. And then we're just going to say like 5. Okay, 5 milliseconds is not like not that fast. Like local SSDs, you should be getting that. And the really interesting thing here is that the way that it falls off. So like your numbers will be fast, 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 but then once you exceed the IOPS limits, you can see it jump from like really tiny numbers to really crazy numbers. So let's just see. Um, 99, so we'll do 99th percentile. See, there's this max latency time, and this was the I can't remember exactly, but I'm pretty sure that this was the original parameter that I tried to use before, and it was just like it would just exit, and I was like, no, this is not what I want. So latency target is actually a time. I'm doing this latency percentile float, so I'm not sure if it's that or I don't know. Find out. See if it's 99 or if it's oops. And then latency window. Let's just see what happens when it does it at 1S. Okay. I have to refresh my memory here. Page cache. Yeah, drop caches. There we go. What is it? It's like proc sys VM drop caches. And yeah, cool. All right, run this. Without units, it is in microseconds. Yeah, I thought I put a unit on there. Did I not? Oh, give me a little love here. Percentile is 99. I don't know what. So I put a unit of S on there. So that should be okay. And let's just go ahead. You know what? I'm gonna whoops. I'm going to direct. So I'm gonna oops. This is gonna test the raw performance of the underlying device without relying on page cache. So let's just go ahead and now that we see that, yeah, see, like look at those numbers drop like crazy once we switch to direct IO. So instead of running for 10 seconds, okay, I did something wrong there. It's still running all of the jobs so simultaneously. So maybe I need to put Stonewall in each one. Ah. Okay, still doing all of them, still not running for very long. Runtime 60 seconds. What have I done wrong here? Okay. Maybe I runtime. Did I not include? Yeah. don't think it's this. I wonder if it's just, no, still not doing it right. If anyone is in the manual and wants to throw out any suggestions, I'm happy to get a hand. Let's see. IO engine. No. The issue is the timing. Time based equals 1. Yep. That's fine. Seems to be one of two things happening. It's either just exiting right away. And by the way, it's also, I have it set for 60 seconds and it's exiting way before that. So maybe let's just get rid of these latency targets for now. Or, okay. Let's see what happens when we do this. Okay, I don't think that this was there before. So did my latency target mess it up? Yeah. I moved it to each job. I kind of thought that the global settings would be inherited by each job. Maybe not. Okay, so this is running here. So this is kind of interesting. So here we've got job 1 running. We're doing only 7 megs a second on reads. So what we probably need to do here is run multiple jobs. So I think I'm going to add num jobs here because we're not even close to the total throughput of this device. Come on. Thought it was jobs. Dum. So let's see. Okay, so each of these has, so maybe runtime needed to be added to each one. I should probably try. Okay, so let's just stop this for a second, and then we'll go to this again. We'll add these back. We'll see if the issue, and then also I'll just make this 10 seconds. Interesting. So it went ahead and just so it did, the latency target did not work the way that I thought it was going to work. Latency run, that's what I need to set. Oops. Latency run. Why did it not like that? What is this, not in the latest version or something? I am running latest. Let's see. I think it's like the first one doesn't need it. All subsequent runs will use that to pause before they run until previous one is done. Yeah, I think you're right. If why did it not like latency run? Did I didn't like fat finger that, did I? Oops. Come on. No. Right? I'm not like just, oh, come on. Get out of here. Okay, so this does not like that. That's unfortunate. So this stuff, maybe I need to do, maybe I actually need to do a build of the main branch for that. Okay, so let's just do, I think it's what? It's either jobs or num jobs. Let's see. For job logs, group reporting, num jobs, yeah. Oh, there's no underscore. Okay. So let's just go ahead and add that. Yeah, that's what I thought it was, Nate, but yeah, it's like randomly not using a underscore. Not cool. So this is going to lay out some stuff. Let's see. So now I've got IO latency, or sorry, IO stat running down here. Just run it for a while. Okay, so this is actually right around what I'm expecting from the perspective of throughput, because it's, I think it said it's capped at like 128 or something like that. And this is, if you can't read this, this is like 120. So okay, so it's pretty close to what they advertise as the max. But the interesting thing is here is if you start looking at like writes a second, it says like 966. So these might be doing like very large like bulk operations, just get the file set up in the first place. See what else we can use in here that's useful. Okay. Oh, you know what? This isn't going to work. I need to change the file size because it's going to run out of space. Come on. Can't just lay out tons of files that are 10 gigs when you only have 100. There we go. So since we're using a bunch of files, let's go with 1 gig files. And maybe this will be a little bit faster. Go in here, let's kill that. Yeah, see, this is just me messing around is already like filled up almost half the disk. But this should be a little bit better. So this is going to be eight. What do I do? Eight files. Yeah, 8 files. Each of them is 1 gig. We'll see what this does. Um, see what numbers we get out of this. Again, this is like literally just trying to figure out what the right configuration file format is here. Another test down the line, encryption versus not. Probably nice to know if that affects performance at any point. Yeah, you see throughput here, 125 and 3,000 IOPS. So I haven't done the math yet, but it'd be interesting to check what their maximum number of check those IOPS with different sizes. So let's see. Okay, so this is only going 4, 8, and 16. I probably, next test, I'm just going to do another one. I'm going to add another one down here. And we will run this with 64. And then might as well just do 128. Okay. Oh, and I've messed up the window again. And it's still messed up. Should probably like put something over here in this corner so that put like a sticky note. Don't go here. And yeah, so as long as I don't overlap that sticky note, we should be in good shape. Okay, so let's see. This is doing its thing. And that actually is right exactly at the IOPS count that I was expecting to see. So, okay, we've got our first job. Whoa, why did it do that? Still says group ID 1. Did I not? Does Stonewall need to be first? I didn't think it did. It's a really weird thing for it to like matter with the order. I don't know why it would Stonewall on that. All right. Still not sure why the group reporting, and this is something honestly that I forget every single time I do this. I should have probably just looked it up at a time. There we go. Okay. So it was, I think the thing that I noticed was, oh, I know these are separate groups. Do I need to use Stonewall says do they are separated by Stonewall. Weird. All right. Well, let's see what this does and then get an idea of what's going on. In fact, I don't know why I'm deliberately like just taking like a long time for no good reason. I actually have like some FIO stuff that I've done before. Maybe we can use this. So let's go over here. See, I didn't do I do new group. And this says jobs. Unless I misunderstood what num jobs is supposed to do. I don't think I do. I'm pretty sure that it's within each group. Right? So this should be blocking between the different jobs. This is actually what I was talking about earlier with the environment variable. So I don't understand why it's doing that. Like what? See, it says starting 48 processes. That's right. And so I'm getting the number of IOPS that I'm expecting. I'm getting really, really low throughput. So we've definitely hit the IOPS number here, but I'm not sure if it's running. So here, so it actually is starting up 8 processes. Am I just not understanding the output? See, because here, So this ran for 10 seconds. Yeah, okay. So I'm just reading the output wrong. So this is going through and it runs each job. Oh, see, this is wait, let me see where you get it. Yes. Okay. This is what I want. This is doing what I want. I'm just reading it wrong. So this is actually ticking down. This says ETA 1 minute over here. This is actually running each of these groups. And now this is up on the, this is definitely running the larger one. Oops. There we go. Sorry about that. All right. So this ran for a minute. This ran a whole bunch of jobs. Let's look at the output. So these are just this end statistics. So group 0 is the 4K one. This was doing 13 megs a second. And if we look up here, it's actually probably better that I just go up here. So here's what I'm looking at. It says BS0, group 0, jobs equals 8, right? Reads 119 megs a second, 467 IOPS. But then here we see read IOPS 3200. So this is 3000 IOPS. Bandwidth 12.9 megs a second. Our latency numbers are here. So the performance definitely falls off here. This is 10 milliseconds. So the performance sort of goes away a little bit. The second group, BS8, this is the one where we're doing 8K reads. So it's still hitting this is hitting reads IOPS 3000, right? Reads IOPS 3200. So they're both right on the same number of IOPS, but this one is doing bandwidth 12.9 megs a second, bandwidth 23.9. So this is roughly, it's doing double the IO, but it's doing it, but it's doing bigger blocks. So you still get the same number of IOPS. And this is only a 10-second test. I'm going to rerun this in a little bit once we get these numbers going. But this is actually exactly what I was expecting to see. So when you see block size 16, still doing 3000 IOPS, but now we're up to 47 megs a second. So we've once again, basically, we went from 8 over here, it was 23. And then when we go to 16, it's 47. So this is double the size of the blocks in IO. And we get double the throughput, but we run out of IOPS. So this is useful information. And the reason why this is so useful, and I need to save this output right here because this is incredibly valuable. This is basically telling us that our read performance, we definitely want to be using for streaming operations. Like when we start, and by this I mean like if we're doing compaction or repair, anything we're doing lots of sequential reads, we really want to be able to take advantage of this. In fact, I could fire up, if I were to fire up a Cassandra node, and I could just fire it up on here. That's for later. I'm willing to bet that if I were to fire this up, I could, if I added in a buffered reader on compaction, I'd be willing to bet that we would see better compaction throughput. So there's an optimization here specifically for EBS that we should be using, because it doesn't make sense to require a user to like set read ahead if you're doing random IO, because they're like, it's unnecessary, because you start, like, if you have, like, let's say a 3 terabyte, 2 or 3 terabyte workload and only like 20 or 30 gigs of RAM available for page cache, you're going to see a ton of page cache churn, like if you're accessing the entire data set. So it partially depends on your page cache effectiveness. It just doesn't make sense to have to rely on read ahead in a database in order to achieve good performance on sequential reads. The database should do that for us automatically. So this is basically like, I'm going to run this longer, and then I'm going to do a nice write-up and submit something. Because here when we hit 128, here's where we start to see that we actually hit the bandwidth limit. So this is at 128 megs a second, and our IOPS number goes down. So here, 64, going from 64, we hit our bandwidth limit basically, and then we see diminishing returns here on 128. So 64 might actually be the sweet spot for this particular type of workload. And these latency numbers do get a little crappier. You know, our 99th, like these lower percentiles. So we are seeing consistently that we're getting like 4 milliseconds, and versus here where we're seeing it's more like 2 or 3, and then it kind of spikes up to 4 right around, you know, right after P99. So this is the problem. So we either read more and hope that we're like finding the right balance of IOPS and throughput, or we read less and we risk artificially hitting our IOPS limits. So the reason why this matters so much is because if we're streaming and we're taking tiny little bits, and we're using, if we're reading 4K at a time, let's say, because there's a lot of really good use cases for 4K compression. Like, and when I talk about 4K, there's two things. There's page cache and there's the compression chunk length. So the compression chunk length is what determines the size of the uncompressed data page on disk. So if you have something like counters or lightweight transactions, you want that to be super small, because counters and lightweight transactions do a read before write. So if you start hitting counters, you want to be deserializing as little data as possible. You do not want to be decompressing tons of data. Like by default, prior to either 4.0 or 4.1, it was 64K, which is crazy. And then you've got read ahead on top of it. So reading in a ton of data, not that good. But this to me is really interesting. These numbers are fascinating, because this kind of gives us, or this gives me at least, enough evidence to kind of discuss the diminishing returns on read ahead and the effects of read ahead on EBS performance for small reads. Like, for example, if you were to set read ahead on your drive to 64K, then you would only get 2,000 IOPS, but you saturate the bandwidth. Okay, so if you're doing random reads and you go from 3,000 IOPS on smaller reads, and then you say, hey, I want to make sure I'm optimized for streaming, I'm going to use 64K read ahead. Well, you actually lose 50% of your IO operations that you're going to be doing for random reads. So great, you end up getting like, you know, you can use more bandwidth for streaming, which is great, because streaming can go faster, but your performance overall, like the rest of the time when you're not streaming, is crap. And that's like a really stupid trade-off to have to make. Like, we shouldn't have to do that. So this is actually really, really good evidence for me I'm just going to go ahead and run it again. And this time, like, I'm going to run it over. Let's just get rid of this latency target business because that thing is lame. I'm going to run this. Oh, let's do this. Cool. Wait, didn't do it there. Oh, oops. No. Is it that? Cool. Let me make sure I didn't break it. In the process of messing around with my Vim replace stuff. Okay, so we're doing direct IO. We are reading. There we go. Runtime 60 seconds. Okay, so we're gonna do a bunch of these at 60 seconds. And this block size 256. This is important because this is actually the default. This actually isn't the default. The default read ahead is 128K, but it's one past it, and I can wait a minute for this. So let's just go ahead and see what happens. In fact, let's write these results out to a file. I'm going to be using this data. Let's see. Come on. Oops. And output equals, let's just do results. And then let's just go with this. Why? Job global dropped. What? Oh. Dumb. Get rid of this. Fun. Okay. So while this is running, if anyone has any questions or anything, feel free to drop them in the chat. I have a moment here where this is going to be running for a couple of minutes, so I'll probably just ramble for a little bit and let this thing finish up. This is to me, this is really exciting. Like I actually really love to have a solid understanding of trade-offs. So I'm probably going to end up writing this up for the project, but I'm also going to share some of this information in a blog. So I'll do a blog post on this. So if anyone's interested in reading kind of my summary on it, it'll be up there. You don't have to go back and watch the entire hour and a half long stream. Yeah, I think it's a good idea to put things in our database that kind of take advantage of the common hardware that we're going to run on. Like, I don't know, that just doesn't seem like a crazy idea to me. The fact that if you run this setting, and you were to set up streaming or compaction and you were to use EBS, the fact that if you use small values for read ahead, that you'll be limited to, I mean, right here on the screen, it's doing 23 megs a second, and hitting the IOPS limit. Or if you use like a higher, higher number, you can actually get um, better throughput, but worse latency. I don't like that trade-off. I want the best of both worlds. So what I want to do is to probably, I think the best case is to figure out, like, it seems to me that we want to take advantage of the maximum size of the IO requests in a buffered reader for those streaming operations, and then everything else we just leave. So that's going to be my thing, and maybe we can get, I don't know if we're gonna, I don't know if this is something that folks are going to be okay with getting in Cassandra 5, because we're already in beta, and it's like all of a sudden start changing the behavior of streaming and whatever. That might not be thoroughly appreciated. But if folks are interested in testing this or using it, I could probably, like, this could, to me, it seems like it might be useful if you're running EBS and you want to be able to expand your cluster faster. I think that it would be fairly straightforward to do a streaming patch and a compaction patch that use all the stuff that I'm talking about. So if you are on EBS, the main reason why you want to do this is so that you can spend less. Like, if you're already using GP3, this can be set up to cost a lot less money. So, if you're interested in this sort of thing, like, reach out. Like, we can talk about getting a patch for it, and especially on the older versions, like on 3.0, 3.11, you're not going to be able, like, nobody's going to have the appetite to start making changes to how IO is handled. In those branches, this would be one of those things that would go only forward. So, maybe this is like a trunk thing, but once the patch is there, it becomes easy enough to go ahead and backport. So anyway, I've got what I wanted out of this, which is understanding the impact of sequential, the impact of your request size on sequential IO performance. We can see that it's harder, or you end up hitting your IOPS limit and not your bandwidth limit, and at smaller request sizes, and then at larger request sizes, you do end up hitting your bandwidth limit. So, yeah, I guess looks like this is getting close to done now. I'm pretty sure this is actually almost done, because, yeah, ETA 1 minute. So I'll just wait for this to finish. When it does, I'll review it, and then that'll be it for today. There might be an interesting kind of thing on future one on EBS, looking at EBS optimized versus not optimized, or looking at higher throughput settings. I don't know. Definitely leave a comment or something if if you're interested in seeing this type of stuff, because I just think this is really interesting. But I'm borderline obsessive with this sort of thing. So. Almost done. Okay. All right. Yeah. Look at that. So if we were to run, so let's suppose that we have EBS and we're streaming and we have read ahead set to 4K and you're dealing with like fairly small blocks, like on a lightweight transaction table, and you're using these settings, you are going to be capped on the IOPS. And with this, it is, what was it? 10. So this throughput is supposed to go up to 125. We're seeing 12.5. So you're only getting 10% of the total throughput of this device. And your latency numbers are okay, probably acceptable for a lot of workloads, like P99 at 3.5 milliseconds, spikes up to 10, not fantastic, but whatever. And then, we go 8K, all of a sudden we've doubled it again, 47. So our sweet spot for EBS, in order to have a decent back and forth on throughput in IOPS, is right over here. Oh man, we didn't should have run a 32. 16 looks pretty good. I'm just going to really quickly run a one at 32 because I'm kind of curious. And I'm just going to get rid of these guys. I don't need this anymore. Oops. Can I just tell it to run one job? Or like just one group. Just run one group. Don't run them all. No, it's okay. All right, I'm just going to go and run this in my own time. And I'll post a summary of this stuff. So, all right, well, thanks everyone for joining me. And I hope that you found this a little bit interesting. I'm personally quite curious as to what happens when we hit a block size of 32. And going to get some more details about this and figure out a little bit more about EBS. Probably try to optimize EBS optimized versus non-optimized and some other things. Section name. Oh man, look at that. It's 32K. Let's just do results. Let's just first. Of course, I forgot the name. BS32, BS32. Let's see if that works. All right, Nate, it's on you, buddy. Let's see if it worked. Exactly. Fingers crossed, pal. Let's do it. It's like, no. Why? Why? Do it. Just almost with space. That's fun. All right. Well, I don't know what's going on here or why it's like not. There it goes. Yeah, I don't know. It was just stuck, and I didn't feel like profiling it or tracing it. Yeah, definitely. Okay, so here I am seeing numbers that are a little bit more in the middle. So we've got 93.8. So let's just results first. So the last test that I ran was the 16. That one we're seeing 3,000 IOPS and 47. Here we're seeing 3,000 IOPS and 93. So it looks like the sweet spot might be 32K for read ahead. Or at least for the block size, not necessarily read ahead, but I mean, it does translate. So here we've got, yeah, all right. So we do higher. The latency numbers look okay, but higher IOPS than 64, but lower throughput. Yeah. Yeah, slightly lower throughput. I think that this is probably the sweet spot. I think that this is because you want to be able to still maximize your IOPS, right? Like it would be in the case of compaction or streaming, you definitely want to maximize your throughput, right? So there, we probably want to go with a 256K buffer, because that allows us to read, or maybe not actually. Well, it's actually hard to say because it's going to depend on like if I were to use a bigger drive, the numbers might be different. So I think the important thing here is I'm going to keep this FIO config because this is really useful. I'm going to keep the FIO config. I'll publish the FIO config, and I'll publish the resulting data. And I'll kind of do a little bit of analysis along the way to break it down. But I think that this is really useful, and I'm gonna get this up in the project and see if we can make some awesome stuff happen. Okay, that's it for real. This time I am done. I really appreciate everyone coming by. Nate, thank you very much for your help and the back and forth as I ran this test. I'll be, like I said, I'm going to save the results. So if there's another test, I can start taking a look at it. Also, probably want to look at random IO. Probably be a good idea to start looking at random IO and the effect on the page cache. And again, I need to get these BCC tools fixed because I've once again broken them. Yeah, so hopefully this was helpful, and I will see you soon.